Scientists have made a groundbreaking discovery with NASA's James Webb Space Telescope. This rare, gravitationally lensed type Ia supernova, known as supernova H0P, is not just another cosmic explosion. It provides a powerful tool to measure the expansion rate of the universe, known as the Hubble constant. This discovery could help resolve a long-standing debate in cosmology, known as the Hubble tension. But what makes supernova H0P so important, and how does it contribute to our understanding of the universe's expansion? Let's explore this extraordinary discovery and its implications. Supernova H0P is a unique supernova observed through gravitational lensing, a phenomenon where a massive object, like a galaxy cluster, bends the light from a more distant object, creating multiple images of it. In this case, the galaxy cluster PLCKK, located 3.6 billion light-years away from Earth, acted as a lens, splitting the light of a distant supernova into three distinct images. This effect allows astronomers to study objects that would otherwise be too distant or faint to observe in detail. Type Ia supernovae, like supernova H0P, play a crucial role in astronomy due to their predictable brightness, which makes them standard candles. Knowing the brightness of these supernovae allows scientists to determine their distance by measuring how much their light has dimmed on its journey to Earth. This type of supernova also provides essential measurements for understanding the rate of the universe's expansion by combining distance measurements with redshift caused by cosmic expansion. Interestingly, the Hubble Space Telescope captured images of the same galaxy cluster in 2015, but supernova H0P was not yet visible. Fast forward to 2023, when the James Webb Telescope, during observations for a specialized program, captured three bright points of light that were missing from Hubble's images. This immediately led researchers to suspect they had discovered a new supernova. Led by Brenda Fry from the University of Arizona, the team quickly analyzed Webb's data and confirmed it was indeed a supernova in a distant galaxy behind the PLCKK galaxy cluster. Gravitational lensing had split the supernova's light into three separate images, allowing scientists to view the same cosmic event as if happening at three different points in time. The Hubble constant is a key parameter in cosmology, describing the rate of the universe's expansion. To measure it, scientists need two elements: the distance to far-off galaxies and the speed at which they are receding. Local measurements of the Hubble constant often yield a value around 73 kilometers per second per megaparsec, while measurements of the early universe, like those from the cosmic microwave background (CMB), yield a lower value around 67 kilometers per second per megaparsec. This discrepancy, known as the Hubble tension, is one of the greatest mysteries in cosmology. The SHOES project, led by Nobel laureate Adam Rees, has extensively measured the Hubble constant using type Ia supernovae. Findings from the project suggest a higher value for the Hubble constant, highlighting the existence of the Hubble tension. Supernova H0P adds a new dimension to this debate, providing an alternative way to measure the expansion rate using gravitational lensing. This is not the first time gravitationally lensed supernovae have been used to measure the Hubble constant. For example, the supernova IPT-16 Goi, also observed by the Hubble telescope, allowed astronomers to study cosmic expansion by measuring time delays in the lensed images. However, supernova H0P stands out due to the high precision of measurements enabled by the James Webb Telescope, offering a clearer understanding of the Hubble tension and potentially advancing our ability to resolve this cosmic puzzle. Several theories have been proposed to explain the Hubble tension. Self-interacting, dark matter SID. In this model, dark matter particles can interact with each other, influencing the formation of structures in the early universe and potentially affecting measurements of cosmic expansion. Evolving, dark energy. Changes in dark energy's behavior over time might account for the difference between local and early universe measurements of the Hubble constant, impacting the expansion of the universe at different stages. Modified gravity, MOT. This theory suggests that the laws of gravity may change on cosmological scales, requiring adjustments to equations to reconcile local measurements and data from CMB observations. This idea may help explain the Hubble tension without relying on dark energy or dark matter. These models provide insight into possible solutions and show how our understanding of physics may need to evolve. The discovery of supernova HOP with the James Webb Telescope could represent a major breakthrough in addressing one of the most significant challenges in modern cosmology. Gravitational lensing offers scientists unique tools to measure the Hubble constant and could bring us closer to a new understanding of the universe's structure. While the Hubble tension remains an unsolved problem, each discovery advances us toward an answer that might reshape our view of cosmic history. Subscribe and hit the notification bell for more exciting discoveries and explorations of the universe's greatest mysteries. The first flight of the Orion spacecraft was a milestone in the history of space exploration and laid the foundation for future missions to the Moon, Mars, and even beyond the Solar System. This flight, which took place on December 5, 2014, was not only a technical test, but also a symbol of humanity's return to ambitious space exploration projects. Let's break down how it happened, what technologies were used, and why this craft was such an important step forward for NASA and world science. Before you send people into deep space, you need to make sure that the ship's systems work flawlessly in the most demanding conditions. Outer space is a hostile environment. High speeds, intense radiation, and extreme temperatures can knock out even the most robust systems. To understand how Orion will cope with such challenges, NASA decided to conduct a series of tests without a crew on board. The main purpose of the test flight was to assess the performance of all the ship's systems, from navigation to radiation protection. This is important because in the future Orion will be the main vehicle for delivering astronauts to the Moon and onto Mars. Such a complex vehicle must be able to withstand enormous overloads and abnormal situations, and the only way to test this is to fly it in real conditions. Orion was launched using a Delta for Heavy rocket, one of the most powerful rockets in the world. From the first minutes of flight, it was clear that this spacecraft was built to overcome serious challenges. Once the craft reached orbit, it began its journey 3,600 miles above Earth, 15 times higher than the orbit of the International Space Station, ISS. This was the first meaningful test that allowed scientists to see how Orion would behave away from Earth's protective magnetic field. A key part of the test was passing through the Van Allen radiation belts, zones of intense radiation surrounding the Earth. These belts pose a serious threat to spacecraft and their systems. Orion was equipped with special radiation shielding that was tested for effectiveness under real-world conditions. For future missions, it is critical that the ship can safely transport people through such dangerous areas of space. The Orion was designed with all modern advances in space technology in mind. One of its features was the emergency escape system, which is supposed to protect the crew in case of a problem during the launch phase. This system can instantly pull the capsule with the crew away from the rocket if a critical situation arises. Another important part of the ship is its heat shield, designed to protect it during re-entry into Earth's atmosphere. During the flight, Orion traveled at speeds of more than 20,000 miles per hour, about 30 to 1,000 kilometers per hour, and its heat shield encountered temperatures of up to 4,000 degrees Fahrenheit, about 2,200 degrees Celsius during re-entry. This was one of the most extreme tests for the entire mission. The success of this part of the flight gave confidence that the craft could safely return to Earth after long missions. The spacecraft is equipped with ultra-precise navigation systems and is capable of processing up to 480 million commands per second. This incredible performance allows the spacecraft to autonomously navigate in space and process huge amounts of data acquired during the flight. After completing its journey to the far reaches of orbit, Orion began its return to Earth. The ship entered the atmosphere at tremendous speed, creating a plasma cloud around it. It was one of the most tense moments of the flight. For several minutes, communication with the ship was lost as signals could not penetrate the hot layer of plasma. At this point, Orion was fully autonomous. When the ship successfully passed through the atmosphere, it deployed its huge parachutes. These parachutes were specifically designed to slow the descent from 300 miles per hour to a safe 20 miles per hour before grounding in the Pacific Ocean. It's important to note that Orion's parachutes are some of the largest and most reliable ever built, and testing them was another key part of the mission. The first flight of Orion was a huge success for NASA and the entire world space industry. It showed that the spacecraft was ready to perform complex tasks in the extreme conditions of space. The data collected during this flight gave scientists valuable information about how the ship's systems would behave in future missions. With this mission, NASA is one step closer to realizing its ambitious plans to explore the Moon, Mars, and other planets. Orion is not just a spacecraft, it is a symbol of humanity's desire to explore new worlds. It combines advanced technology, safety, and versatility that will allow astronauts to go where no one has gone before. The story of Orion's first flight shows how complex and important space missions are. It was not just a test, but a step into the future, where humanity would be able to go beyond our planet and explore the far corners of space. This flight opened a new chapter in the history of space exploration and inspired many to dream that one day humans will travel to the stars. Greetings to all space explorers. Today we're going to travel to the very edge of the solar system, where the mysterious Kuiper Belt hides. It's a vast region full of icy objects and mysteries, including one of the most famous dwarf planets, Pluto. What makes the Kuiper Belt so interesting, and why is Pluto, once considered the ninth planet, now at the center of controversy among scientists? Let's find out. The Kuiper Belt is a ring of icy bodies that lies beyond the orbit of Neptune and extends billions of kilometers from the Sun. This cold repository contains remnants of the material from which the solar system formed. These objects, called trans-Neptunian objects, include ice blocks, comets, and dwarf planets such as Pluto, Haumea, Makemake, and Erid. The Kuiper Belt is something of a treasure trove of ancient materials. Studying these bodies can give us insight into how planets formed and what conditions existed in the early solar system. Pluto was discovered in 1930 and for decades was considered the ninth planet in the solar system. However, in 2006, the International Astronomical Union decided to remove it from the list of planets and classified it as a dwarf planet. The reason was the discovery of many objects similar to Pluto in the Kuiper Belt. Pluto just happened to be one of many. Pluto is slightly smaller than our Moon, and its orbit is more elongated and tilted compared to the orbits of other planets. In addition, its mass is too small to clear its orbital space of other objects, which is one of the criteria by which planets are classified. Despite being demoted to a dwarf planet, interest in Pluto has only increased. In 2015, NASA's New Horizons spacecraft made a historic flyby of Pluto, transmitting the first detailed images of its surface to Earth. This was a real breakthrough. The research revealed that Pluto has a huge heart-shaped plain, icy mountains, and possibly even a subsurface ocean. All of this indicates that Pluto is a complex and surprisingly active world, not just an ice lump on the edge of the solar system. The Kuiper Belt remains an object of active research and attracts the attention of astronomers around the world. One of the main mysteries is the presence of large objects, such as Orion, which is almost as large as Pluto. The question of how exactly such large bodies were formed in such a remote part of the solar system still has no definite answer. There is also a hypothesis about the existence of the so-called ninth planet, a massive object that could explain the strange orbital motions of some trans-Neptunian objects. It has not yet been discovered, but if such a planet exists, it could change our understanding of the structure of the solar system. Studying the Kuiper Belt not only helps us understand the past of the solar system, but also gives us clues to the search for life beyond it. Kuiper Belt objects are icy bodies that contain organic molecules, the building blocks of life. On Pluto, for example, traces of frozen nitrogen, methane, and carbon dioxide have been found, suggesting the possibility of subsurface oceans that could support life. In addition, similar belts have been found around other stars, indicating that the formation of planetary systems is universal. The Kuiper Belt is a cold and remote region full of mystery and possibility. It reminds us that there are undiscovered worlds hidden at the edge of our system, and Pluto remains one of the main mysteries of this frontier space. Perhaps in the coming years, new missions will help answer the questions that continue to preoccupy scientists. Why and how did this belt form? And is it possible that it hides conditions suitable for life? If you enjoyed this video and want to learn more about the mysteries of the solar system, don't forget to subscribe to the channel, put a like and click on the bell. There are many exciting discoveries ahead.